So let's look at the first question now. A crane is lifting a structural steel section with a weight of 8,000 pounds. The slings used are 20 feet long and the hook is 17 feet above the structural steel section. So I'm going to start by writing out our formula. So our formula is T equals W N times L over V, where W equals our weight. Okay, so that's the number of pounds. Our N is the number of slings. So here we got, in this picture, we got 1, 2, 3, 4. So number of slings equals, we'll say number of slings. And then L is the length. So from the hook to the lifting point, there's a length there. So that's our length. And then the last one here is our V, so that's our vertical. So that's the vertical distance from the hook to the bottom. So that's our vertical. Now let's do some calculations. So now that we have our formula and we have what we're looking for, let's write in what our givens are. Okay, so we have a weight of 8,000 pounds. So right here we can write in 8,000. Okay, number of slings that we have here is 4, but we're going to write this in as 2, and I'll come back to that later. The length of the slings are right here, so we have 20-foot slings, and our vertical distance, so the distance from this structural steel to up to the hook, is 17 feet. Okay, so when we have something that we're lifting, if this is our piece that we're lifting, this is my very rough sketch, and then we have a hook on a crane, and then we come down and we have 1, 2, 3, and 4 slings that come down. This sling here and this sling here are going to carry the weight, and these other ones, we don't know how much they're taking. It could be any of the two. We don't know how much these other ones are taking because all slings are slightly different, but it's not going to be 2 slings beside each other. There's 2 slings across each other, and then the other 2 take the rest of the weight, or more or less work as balancing. So it's safer for us to go by 1 sling and 2 sling, even though there's more than that. So unless there's a specific lift where we've guaranteed the matching set of slings, that everything is equal length with a turnbuckle or some kind of mechanism to ensure it's absolutely, or we put load cells to make sure they're all holding the same weight, we're going to go ahead and just use 2. So now if we write out our formula, so we're going to write out this formula, and we're going to plug in these numbers right here, and for this one the 2. So we have 8,000, okay, divided by 2 times 20 divided by 17. So 8,000 divided by 2 is 4,000, and 20 divided by 17 is 1.18 or 176, but I'll just say 1.8. So I'd leave that in my calculator, times 4,000, and what we get is a sling tension or safe working load requirement of 4,705.9, but we don't have to go into that. We can just say 4,706, and if we wanted to just be cool, we could just say 4,700. That's probably fine. 6 pounds in a lift this big is not going to make or break our lift. So we need to find a couple of, or some slings that are 20 foot long that are able to hold at least 47,000 pounds.